Welcome everyone. So in this video, I'm going to test Google's AI Gemini for its ability to serve as a study partner, I guess. And I'd made other videos on this about a year ago, and I guess, was with mixed results between Bard and ChatGPT. Here's with Gemini. And my motivation was this pops up sometimes, at least on my smartphone. When I search for things, it'll give you the AI generated content. And I just tried a couple videos, maybe you saw, or maybe not, maybe you should see, my externalities and then elasticity video. And I decided that Gemini does a pretty good job with those. Let's see what it does with Cournot. So previously, Cournot and solving other like more complex mathematical things caused it actually kind of great difficulty. But I've asked it now, can you provide a solved example of a Cournot oligopoly problem? I just typed this in, I clicked submit, and I just so that it wouldn't be too loud me typing on the microphone, but I haven't reviewed this, so I don't know what this is going to say. All right, so consider a duopoly model market with two firms, firm 1 and firm 2. The inverse demand is given by price is equal to 100 minus Q. Fine. Both firms have a constant marginal cost of production of 20 per unit. And now it's going to give me my solution. Okay, so let's see what it's going to say. The Cournot solution, right? So this is a standard kind of generic Cournot. So this is like A, the coefficient B or D in like the generic Cournot that you might see in a textbook are both 1, and then the cost is C. So that's this right here. So if you remember the general equilibrium, we know the Cournot equilibrium quantity is A minus C divided by 3, or actually A minus C divided by n plus 1. So here we have two firms, that's n, plus 1 is 3. So 100 minus 20 is 80 divided by 3. So 80 divided by 3 is going to be the quantity we're looking for both firms. Let's see if Gemini knows that. So let's determine the reaction function first. So we write out firm's profit function. Okay, fine. So profit is going to be price minus marginal cost times quantity. That's right. So pi 1. We replace price with the demand curve. Sure, this is right. And then minus marginal cost, everything gets multiplied by Q1. That's also correct. To maximize profit, we take the first order condition with respect to Q1, set it equal to 0. Yeah, that's right. So just cleaning up this algebra first, we're going to have an 80 Q1 minus a Q1 squared minus Q2 Q1. So when we take the derivative of that thing, we're going to get 80 minus 2Q1 minus Q2. That's good. We'll solve for Q1. So that's going to be 80 minus Q2 equals 2Q1. Divide through, and we'll have 80 minus Q2 over 2 is Q1. They're writing it like this, which I really like, because you notice how I just said that? Like, if we solve this for Q1, we might write this as 80 minus Q2, that whole thing over Q1, over Q2, which is a fraction. Anytime you have that sort of scenario, if this thing is nicely divisible by 2, you might as well make that division, because it actually kind of cleans up the algebra when you're solving the system of reaction curves. So they wrote this as 40, fine, and then they made this minus 1/2. Right, this is correct. I would also say, though, like I mentioned, if this is odd but nicely divisible by 2. So like 25, that's nicely divisible by 2, right? 25 is odd. Divide that by 2, it's going to be 12.5, which is fine to deal with, right? Or 13, divide by 2, it's 6.5. So I would say if this coefficient, or if this number right here is even or nicely divided by 2, you want to carry through and just do that division. Okay, fine. So we follow the same steps for firm 2, or just invoke symmetry. So the symmetry argument is both firms have the same costs, and both firms' quantity is treated by the market as the same. So one additional unit of output from firm 1 and one additional output from firm 2 are treated the same by this market. Total, the maximal amount that this market will bear is 100 units. At that point, the good is free, right? It doesn't matter who or both or which or either those 100 units come from. And of course, we don't want 100 units because we don't want the good to be free. But because of that, we have symmetry. And so sure enough, we had firm 1's reaction, we get firm 2's reaction. Now we're going to solve a system of equations. So basically, what I'm going to do is where Q2 appears in firm 1's reaction, I'm just going to replace that with 40 minus 1/2 Q1. And the thing to pay attention to is this minus. when I distribute that across this. So let's see if they do that. Yeah, sure, they wrote this exactly perfectly. So 40 minus 1/2, the quantity, 40 minus 1/2 Q1, that's right. So when I distribute this, I'm going to get 40 minus 20 plus 1/4 Q1. So then when I move this to the other side, I'm going to get minus 3/4 Q1 equals 20. Okay, so let's see. They didn't write that. They didn't write that out, and so that is their mistake. So they didn't. So okay. So for solving this right here, they're telling me Q1 is going to be 20. And we can see that you can see that this doesn't work, right? You can see this doesn't work. So they've solved this thing. They said Q1 is 20. If Q1 is 20, when I plug this into firm 2's reaction curve, I should get the same number. So 40 minus 1/2 times 20. 20 times 1/2 is 10. 40 minus 10 is 30, which they got. But we have a problem because they're saying Q1 is 20 and Q2 is 30. So their work doesn't pan out. This isn't correct. So they were good until that point. And this is like, I actually kind of thought they were going to get it right when I got to this step. So this is really bad. This is really bad because you could think that this is correct because they are convincing about this. And this is not correct. So what's the problem? Let's just kind of work on building out what this line needs to be. So this is the next line is going to be 40 minus 1/2 times 40. So 40 minus 20 is 20. And then it's going to be minus 1/2 times 1/2. Negative 1/2 times negative 1/2 is 1/4. So the line that I need to write here is Q1 equals 20 minus 1/4 Q1. You could write that down for yourself. So the next, when you clean this up, it's going to be Q1 is equal to 20 minus 1/4 Q1. Then Q1 is equal to 20 plus 1/4 Q1. I would have caught that error immediately when I wrote this out. Because when you move that 1/4 Q1 to the other side, this Q1 becomes a 3/4 Q1 equals 20. And if you get a 5/4 Q1, you know you made a mistake, and you know the mistake was a sign error, actually. And that happens pretty frequently, just as I misspoke, sometimes you might have a negative on that 1/4. It needs to be positive, so when you subtract it from both sides, you get a 3/4 Q1. That's the quintessential Cournot step, is you see 3/4 Q1 equals some number, and then you know you're on the right step, on the right track. Okay, so you're following with me, I hope. We have 3/4 Q1 equals 20, if we wrote this out. Multiply through by the reciprocal, so it's going to be 4/3. So Q1 is equal to 4/3 times 20. 4 times 20 is 80 divided by 3. That's what I said initially was the solution, right? And that's why. Okay, if you plug that into the reaction curve, what happens? Okay, so let's go back to this reaction curve, and rather than plugging in 20, we plug in 80 over 3. What happens? Let's see. So it's going to be hard to do in my head. I know what the answer is going to be, so I could cheat. But so we're going to have minus 1/2 times 80 over 3. So that's going to be minus 80 over 6. Minus 80 over 6. Let's see if I can clean that up nicely. So that's going to be 40 minus 80 over 6 is the same as 40 minus 40 over 3. This 40 minus 40 over 3, I can change this 40 to 120 over 3. That's another way to write 40. So 120 over 3 minus 40 over 3 is 80 over 3, right? Okay, so my solution is correct. I just demonstrated that just right here. This market price is also incorrect. I don't want to bother doing that. You have to calculate 100 minus 160 over 3 to get the price, right? And we've done enough already to show that they're actually not correct. So, look, I guess you get what you pay for. Gemini has come a long way. It actually got mostly correct. It just didn't solve this algebra correctly, which is what we know about large language models. They kind of suck at algebra, but whatever. So It's not a horrible tool, I guess, as a study assistant. Here's my price elasticity of demand stuff. We don't care about that. It's from the other video. It's not a horrible study tool. I would say, like, definitely use it with caution would be my advice. I'm sure at some point it's going to be way better. Anyway, I hope you enjoyed this video, and I'll see you next time.